All right, let's get right into it. We're about to pull back the curtain on one of those secrets that seems to separate the coding pros from everyone else. Think of them as cheat codes for writing really, really good software. You've been there, right? You're looking at code from a senior developer, and it's just perfect. It's so clean, so logical. And you're just left scratching your head, asking this exact question. How? How did they know to build it that way from the start? It's easy to think it's some kind of magic, a flash of inspiration that only the chosen few get. But what if I told you it's not magic at all? It's a skill, and it's a skill that you can absolutely learn. See, the secret isn't some innate genius. It's actually experience, all boiled down into a set of powerful tools. We're calling them the developer's cheat codes, but their real name is design patterns. So what is a design pattern really? Well, think of it as a blueprint. It's a battle-tested template for a problem that programmers have already solved thousands of times over. Now, here's the key part. This is not a finished chunk of code you can just copy and paste. It's a concept, an approach, a really smart way to think about a problem. To really make this click, let's step away from the keyboard for a second. Let's think like an architect, because this analogy is going to make everything crystal clear. Imagine you're building a two-story house. You need a way to get from the first floor to the second. Now, you could invent some crazy new system with ropes and pulleys. I mean, it might work, but it would be super confusing, probably expensive, and let's be honest, kind of dangerous. Or you could just use the known, proven pattern for this exact problem. A staircase. It works, everybody understands it, simple. And that's really it. That's the whole idea right there. Software design patterns are just staircases for your code. They're the reliable, well-understood solutions to the common problems we run into every single day. Okay, so that makes sense. But why should you actually go to the trouble of learning and using them? What's in it for you? Well, it turns out you get some serious power-ups for your code. There are 3 huge benefits. First, these are proven solutions. They've been tested for years. Second, and this is a game changer for teams, they give everyone a shared language. And third, they make your code way, way easier to maintain in the long run. Let's zoom in on that shared language idea for a second. Okay, imagine you're explaining your work to a teammate. You could say something like this. I created a class that ensures we only ever have one instance of the database connection. I mean, it gets the point across, but it's a bit of a mouthful, right? Or you could just say this. I used a singleton for the database. Boom, done. In 4 words, any developer who knows their patterns instantly understands the entire structure, the trade-offs, the whole shebang. That's the incredible power of a shared vocabulary. Now, these patterns aren't just a random pile of good ideas. The authors of the famous book that started it all, a group often called the Gang of 4, they organized them into 3 main families. First up, you've got the creational patterns. Think of these as your object construction crew. Their one and only job is to handle how objects get created in smart, flexible ways. A classic example is the factory pattern. Instead of you having to know all the messy details of how to build a complex object, you just ask a factory for one. It's basically the difference between ordering a pizza and having to make it all from scratch yourself. Next are the structural patterns. This family is all about the wiring of your application. They focus on how you can compose different classes and objects together to form bigger, more useful structures. You've probably used the adapter pattern in real life. You know when you're traveling and your phone charger doesn't fit the wall socket? You use a travel adapter. It doesn't change your charger or the wall. It just sits in the middle and lets them work together. That's exactly what this pattern does for your code. And finally, we have the behavioral patterns. These are like the traffic rules for your objects. They define how different objects communicate, who's responsible for what, and how they all collaborate to get things done. The observer pattern is something you literally use every day. Think about hitting subscribe on a YouTube channel. You're the observer. Now, you don't have to keep checking the channel for new videos. When a new video is posted, the channel, the subject, automatically sends you a notification. That's the observer pattern in action. So these patterns sound amazing, right? But here comes the really important pro tip. They are powerful, but they can be a trap. Knowing when not to use a pattern is just as important as knowing when to use one. So when should you grab one from your tool belt? Definitely when you see your code is getting messy with duplicated logic, or you know you'll need to add more features later. But when should you steer clear? Well, if you're just doing it to look smart, that's a red flag. And please, don't use a complex pattern for a simple Hello World script. That's like using a sledgehammer to crack a nut.
All right, let's bring it all home. We've covered a ton of ground here, from what these patterns actually are to why they're so useful, and even when to leave them on the shelf.
So, what are the big takeaways? 1. They're just standard blueprints for common problems. 2. We use them to talk to each other more clearly and to write code that won't give us a headache later. And 3. The golden rule. Keep it simple. Only use a pattern when you actually have the problem it's designed to solve.
Learning these patterns isn't about memorizing them all at once. It's about adding tools to your toolkit one by one. So the real question for you is, now that you've had a peek inside the toolbox, which blueprint are you excited to try building with next?